Now we've moved up from looking in towards the Phragmites reed swamp and that glacial valley to looking across a ridge that divides the lower valley slopes from the other side of the bay here, looking in towards what is called Tranaboo Cove, and beyond it, beyond the peninsula there, is Loch Eyne. And from the studies that we've done at this site, looking into this narrow valley with this ridge separating it, called a col, separating the two parts of the site, we have a narrow valley. And it's through this location here, the narrow valley, that we see this wave of water, the tsunami, coming in from the Tranaboo side and coming across this low col at around about maximum height around about 18 to 19 meters here, and then exiting out through what is now this Phragmites reed swamp. So it is a narrow site, underlain, as we will see, by the bedrock, the quartzites and slates and shales and sandstones of this area, the West Cork sandstone series, overlain by glacial, and we'll see those underlying sediments. And on top of them, inside this valley, we have a distinctive sequence of marine sands with lots of shells that would be living in the intertidal zone and on the rocky shoreline around this coast. So the site now has been excavated. We can see in the far distance, overgrown, but nonetheless quite distinct, a section through the marine sands. And the section is around about a metre thick, and the total thickness of these sands here is at least 2 metres. The thicker sequence, as we can see, exposed in that cliff, excavated out to create a small field, now overgrown but nonetheless human excavated for pasture, and the sands then thinning in the direction towards the Phragmites reed swamp. So it's got a very distinctive geometry to the site, which is consistent with a wave of water coming through as part of this tsunami. The survey that we've done is very much a preliminary one, but it's going into a journal paper, we hope, and it's under review at the present moment. But it's based upon a lot of detailed field work, which, Darius, I think it's best for you to describe. Okay.
Well, yes, if you just look today, and we're here towards the end of April, and would be typically the start of a geographer's field season, you can see already the area is heavily covered by vegetation. And when the sites came to our attention, one of the first things we needed to establish was simply what is the extent of this sand and gravel, of the sand and the boulders, both laterally and vertically. And short of stripping away all the vegetation from the area, which is clearly impractical, the only way we could do it was by undertaking a structured ground survey using traditional surveying techniques of poles, graduated poles and instruments, and also GPS, the modern global positioning system instrumentation, which can give you your location very precisely, both in horizontal and vertically. And we had a student, Abigail, who undertook this research as her master's degree project, and she set out a regular grid of pattern across the col area and surveyed points across this grid to a high degree of precision, so we could work out exactly how high above sea level and the deposits are, and also how extensive on each side of the valley. In addition to this, she also undertook a coring work on a line going along the axis of the valley, using a drill to drill down into the sediment and drill down as far as she could until she reached bedrock or some really solid material. And she was able to bring up samples of the material that she was drilling into to examine it and make sure that it was the sand and the boulders. Obviously she couldn't drill down into the boulders themselves, but she could drill into the sand and verify that it had the shells and other material in it. It was the same material. And by doing this in a transect along the valley, you can work out the variations in the thickness of the sediment as well. Having done this original reconnaissance survey, the results of that showed that the sediment does indeed extend up the valley sides, but it thins as it goes up the sides of this col, and we can interpret it as suggesting a thickening up towards the middle and then thinning down as we get down into the Phragmites reed swamp. Once we had that basic framework, the next stage was to fill in a few of the gaps, and for this other technologies were brought into play. One of these was something known as ground penetrating radar, GPR, and this essentially sends a pulse of radio waves down into the ground and then records how those radio waves are reflected back from boulders or other hard layers within the sediment. And in this we were assisted by a company based in Cork, Murphy Surveys, who came and lent us the equipment, and we did a GPR survey of the extent of the sediments to try to find out in greater detail just the thickness and the distribution of the sediments across the valley, and also the echoes picked up what we suspect are additional boulders within the sediment, obviously, and we could only verify that by digging down into them, which we haven't done yet. So that's the extent of the research done so far. We've also been able to obtain some data from the Ordnance survey in Dublin, LiDAR data. This is data obtained by flying aircraft over the area as part of a much larger survey done by the Ordnance survey, but they gave us a small sample of the data for this area, and the data were acquired by lasers mounted in aircraft that flew over the area, and again they provide a very high resolution, very detailed picture of the elevations at different points across the area. So stitching this data all together, it will enable us to map out to a high degree of accuracy the extent of the survey. And once we do that, we can now start looking at variations within the sediment. We can look at the nature of the pollen or the vegetation in the reed swamp, and start piecing these pieces of evidence together.
Well, what you've described, I think, in good detail there is the sort of science programme and sort of the clinical approach to this. The significance, I think, at the end of the day, is the landscape that we can see around us, which now, of course, is covered with vegetation, and it looks very gentle and very picturesque and very benign. But if we're right in terms of this being the site of a tsunami that impacted the area, what would that landscape look like as a result of the tsunami impact? And of course we have examples from other parts of the world, from Japan, from the Indian Ocean, as we spoke of earlier, from Samoa and from South Africa, so many sites, that when a tsunami impacts, it completely levels the area and redistributes the sediments, it creates new surfaces, and the landscape looks entirely different. So when the tsunami impacted here, then we'd have had significant change, and then the coast starts to develop again from that point. And so the significance of this site is perhaps not so much will we experience another tsunami here in West Cork or in other locations around Ireland's coastline, but what will the impact for people living on the coast be? What will be the significance of it for the functioning of the coast into the future? And of course the significance is that everything will change. We'll have to start from the beginning, and we have to in a sense be aware that landscapes can change very rapidly with these sort of big scale events. At the moment many people, I think, are now very aware that our environment is changing as a function of climate warming, and that sea level, and we started with sea level in Tralispean Cove with the tides, for example, that sea level will rise, and with it the tides and the scale of the tides will change. But that rising sea level will be a very fast event as we go into this next century, where at the moment we have a sea level rise of about 3 millimetres per year. In 20 years' time it will have doubled, and we'll be looking at 6 to possibly 8 millimetres per year. So we'll have something like 0.5 metre sea level rise above present day levels by the middle of this century. And that will change this landscape in, again, a very dramatic sort of way. So the tsunami event is an indication of rapid change, and we can learn a lot from looking at these sorts of events.